Hello. On this video, I want to review a little bit of some ideas we were kind of developing at the end of the first semester. It's going to kind of set up this idea we call inference. So here we go. So what I have here is suppose 55% of the 398 girls at PHS have brown eyes. You take a simple random sample of 30 PHS girls and record the proportion that have brown eyes. Okay? So let's look at this. Should a sample of this size lead to a normal sampling distribution? Show calculations that support your answer. All right, well, let's turn off Van here, and then we get into the stats. So here's our population. 55% of the school of the girls have brown eyes, 45% do not. And we'd like to know, all right, we're going to sample 30 from here. We're going to basically grab a sample of 30. Okay, so n equals 30. And we'd like to know, is this going to generate a normal sampling distribution? We learned at the end of the semester that proportions is one of those statistics where if you sample properly, we'll have a normal sampling distribution. But what are those conditions? Well, hopefully you recall there are two. We want NP to be greater than or equal to 10, and we want N1 minus P to also be greater than or equal to 10. And so in this particular case, N is the number we sampled, which is 30, and then P is the proportion of brown-eyed girls. And so if we would say, all right, let's kind of take that, and we'd have 30 times 55%, which equals 16.5, and that's greater than or equal to 10, so we're off to a good start. And then we take 30 times 45%, and that would be 13.5. And that too is at least 10. In other words, what we are saying is if we sample 30 from a population that's 55% brown eyes, we're expecting to get 16.5 brown-eyed girls. Now, as long as we can expect to get 10, then we're good. But we also have to think about, well, what about non-brown-eyed girls? How many of those would we expect to get? Well, we're expecting to get about 13.5. So as long as you're expecting to get at least 10 of each outcome, your sample size is large enough to generate a fairly normal looking sampling distribution. So in this case, can we assume a fairly normal sampling distribution? Yes, we can. The sample of 30 is large enough. Now, a sample of 20, that may not have been large enough. Okay, like 20 times 45 is only 9. And so we needed to sample, closer to 30 than 20. But moving on. Draw and describe the distribution of the sample proportions. This is also known as the sampling distribution, and includes your calculations. So as we just said a moment ago, because we've sampled enough, okay, we can assume a fairly normal sampling distribution. And now let's try to be more precise about, well, what else do we know about this distribution? Well, the mean would be 0.55. Most likely we're going to get 55% brown-eyed girls in the sample if we're drawing from a population that is 55% brown eyes. But there's going to be a little bit of give and take, a little bit of standard error that we would expect to have in this distribution. So the way we find standard error, you might recall, is this formula P 1 minus P over n. And working out the details, that would be 55% times 45%. In other words, the chance of a brown-eyed, the chance of not brown-eyed, over 30. And we can kind of square root all that. And we get about a 0.091. So let's see, about 3 of those would be about 0.27. So if I add on 0.27, that puts me about 0.82. And if I take away 27, puts me at about a 0.28. So this is what I think the sampling distribution would look like. And then we'll describe it, okay? In words, the sampling distribution, or if you want to be a bit more formal, you could say the distribution of sample proportions, okay, is approximately normal. With mean 0.55 and standard error 0.091. And so that would be, drawing it and then writing a description of the distribution. Okay. Moving on to the next part. What is the probability that your sample has at least 20 brown-eyed girls? Include a shaded and scaled diagram. Show your calculations. So I'm going to go ahead and use the diagram up here. Hopefully that's okay with you, just to save us all a little bit of time. And it says, okay, at least 20 brown-eyed girls. So we're talking about a sample. So when we talk about a sample, we call that p hat. The sample proportion is 20 over 30, which works out to be 66.7%. So we call that p hat. And the question is, well, where is this on our distribution of sample proportions? Well, remember, each of these is about a 0.09, so this is about 11% more than 55. So we'll just pass the first deviation. So right about there is where I expect 667 to be. And we're wondering, well, what's the chance of getting this proportion, or one perhaps that's even greater, right? At least 20 brown-eyed girls means 20 or more. So from a percentage standpoint, 66.7% or higher that have brown eyes. And so we now want to figure out, well, how much is this space right here? So in terms of the calculations, we always show a z-score for this. And so the z-score would be, well, we're observing 66.7%. We're expecting 55%. And we put that over the standard error of 0.91. And we get, in terms of a z-score, about a 1.286 or 1.29, because often z-scores get rounded to 2 decimal places. And so we'd like to figure out, okay, can we take this and figure out what the probability is? So we could use a z-chart. We could also use our calculators using the normal CDF function, and I'll show you 2 ways to do that. I think you're pretty familiar with this. So one way is we could take the z-score, 1.286, that's our low z-score, and then we'll pick an upper bound of 1,000. But that's using standardized values, so the mean of 0 and a deviation of 1. So on a standardized table, and we'll paste that in. And so we get about 9.9%. Now another way to do this, without using a z-score, is we're going to use our raw value of 20 divided by 30. See if the calculator likes that in a second. Our upper bound is going to be some big number like 1,000, but now we're taking standardized, non-standardized, so 55% was in the middle, and that had a standard error of 0.091. And we'll see what this says here. And so once again, it gives you about 0.099, so probably a little more precise this time. So if I was to round it Maybe I call it about 10% or 9.9%, depending upon which of these you've used here. So we can write that the probability of a z-score being 1.286 or greater is 0.099 or 0.10 if you prefer. You could also talk about it in terms of the proportion. The chances that that our p hat, our sample proportion, is going to be 20 over 33 or perhaps even higher, 0.099. Okay. That would probably be the better way to say it, because it says what's the probability that your sample has at least 20 brown-eyed girls. Or another way is to say, just talk in terms of number. Let X be the number of brown-eyed girls in your sample, and the chance that that number is going to be 20 or more. Okay, and I'm fine with really any of these three representations. I guess this one's is sort of most specifically follows the way the question is phrased, has at least 20 brown-eyed girls. This last one here would probably be the most specific. And so that's, again, a reminder of how you kind of find the probabilities in a normal distribution. So now we'll go on to the last one. How many brown-eyed girls are reasonably likely to end up in your sample? So there's that phrase, reasonably likely. So let's remind ourselves what is reasonably likely. In a normal distribution, you might recall this idea called the empirical rule, which said, about one deviation away from the mean, about 68% of your distribution is within one deviation of the mean. Within a second deviation of the mean is about 95% of the entire distribution, and within 3 deviations of the mean is almost the entire distribution, 99.8 something percent of the distribution. Well, we're going to refine that a little bit. The middle 95% is between 1.96 and negative 1.96 deviations. And that's what's considered the reasonably likely range, is that sort of middle 95% of the distribution. So really staying within 1.96 deviations or errors of the mean will give you that middle 95%. So in terms of a formula, it would look something like this. And if we now wanted to apply it to this specific problem, we're saying, well, we're expecting 55% blue-eyed girls. Pardon me, brown-eyed girls. What am I thinking? Sorry, Van. And then we have our 1.96, and our standard error is 0.091. And so doing a few more calculations, 55%, give or take 1.78. And then doing the math on that, we get about 0.372. And again, this is p hat, the sample proportion. It's going to stay somewhere between 37 and 72.8%. So this would be what we call sort of the reasonably likely sample proportions. Now, we have to be a little careful. This didn't say what proportions are reasonably likely. It actually said how many, so number. So we have to remember this is a sample size of 30. And so we have to apply these percentages to 30. So we have to multiply each of these by 30. And so we get about 11.16 and about 21.84. And now it would be X, or I probably don't want to use N because I've used that before, but X, which is actually the number of blue-eyed girls that are reasonably likely to occur in this sample of 30, or somewhere between 11 and 21 or 11 and 22 brown-eyed girls reasonably likely to occur in our sample. Getting, say, only 8 brown-eyed girls or getting 24 brown-eyed girls in our sample, while not impossible, would not be considered a reasonably likely outcome. So hopefully that gives you a little review of some of the topics. And we're going to use these to kind of talk further about this idea we call inference and confidence intervals. So, so with that, I think I will leave you. Enjoy the rest of your day. Thanks for watching.